Okay, this is a test. So this is an intro to signals and systems, and the first two things you need to know, the first three things. Okay, the first thing you need to know is that I'm making this series because I think I can help a lot of students starting off with this class. I think that being exposed to new material for the first time can be difficult, and sometimes the teachers just tend to show slides or some PowerPoint presentation that are just textbook and they don't really explain anything. So I'm going to try to help students that find themselves in that situation. The second thing is you need to know Euler's formula. So just know how to go from any j theta. So j is used in engineering instead of I for the imaginary number, because I is usually for current. So j is just the square root of -1. Okay, and yeah, and then you apply this and you get cos and sine, and that gives you a real part over here and an imaginary part. Second thing is you should know how to do the reverse and go from Cartesian coordinates to polar coordinates. So this is Cartesian and this is polar. Okay, so let's do a couple examples, or solve a couple examples. So for these problems, you need to express each complex number in Cartesian form. So let's do this. So the first step you want to do here is just isolate the alpha, which is 2, and then turn this into cos of 2 pi over 3 plus j sine 2 pi over 3. Okay, now if we just look at our unit circle, we know that here 0, pi over 2, we have 2 pi over 3. So at 30 degrees we have pi over 6, pi over 4 at 45 degrees, and pi over 3 at 30 degrees, or at 60 degrees. And if we have 2 pi over 3, then we just need to take 60 and do times 2, so we're at 120 degrees. This should be 2 pi over 3 over here. And these points are symmetrical, so it's going to have the same coordinates. We know that at pi over 3, we have the points, I want to say 1 over 2 and root 2 over 3. Oh my god. Or root 3 over 2. Sorry. Root 3 over 2. Okay. And because we have 2 pi over 3, and because of the symmetry, it's the same number, it's just that the x term is negative. Root 3 over 2. Alright. So this is equal to 2 times -1 over 2 plus j root 3 over 2. When we multiply by 2, we get -1 plus j root 3. And there you go. This is equal to a plus jb. We have the real part and the imaginary part. Let's do one more example. Be, say 2e to the j, I don't know, pi over 4. Same thing. 2 cos pi over 4 plus j sine pi over 4. Okay. At pi over 4, you know we have root 2 over 2. Root 2 over 2. So what do we get? We get 2 times root 2 over 2 plus j. Oh my god. J root 2 over 2. In a lot of problems later on, the imaginary part does cancel out because they'll probably give you an angle where sine goes to 0, so pi or 2 pi or just k pi, and that'll always cancel out the imaginary part. But for now, you just need to know how to solve these. Pretty easy. We get root 2 plus j root 2. Alright. Okay, now we're going to do the opposite. We're going to solve this problem, but we are going to go from Cartesian coordinates to polar. So we need alpha e to the j theta. Alright, the first step is to calculate alpha, which we know to be the square root of a squared plus b squared, which is negative root 3 over 2 squared. This is going to equal root of 1 over 4 plus 3 over 4, which is equal to 1. So immediately we found our magnitude. Alpha is the magnitude. And now we need to find theta. Now, before we go to calculate theta, you should know this is also sometimes called the argument of z, or just argument of z. But one important thing is that before you calculate, you need to draw the graph of where your point is on the real and imaginary axis, because you might have to change your angle. We know that theta is tan inverse of b over a, but tan inverse only covers from here to here, which is like a negative pi over 2, or pi over 2 to negative pi over 2. It does not cover quadrant number 2 and quadrant number 3. So all you need to do is that if you have a point in quadrant number 2, you need to add pi. So you do a plus pi, and if it's in quadrant number 3, you just minus pi. Right now, we know that our real part is negative 1 over 2, and our imaginary part is negative root 3 over 2. So it'll be somewhere like, I don't know, somewhere on the scale, I'm assuming here maybe. Root 3 over 2, probably less, I don't know. But somewhere here. With a magnitude of 1 that we calculated. And because it's over here, whatever our tan inverse of b over a is, we have to minus pi over here. Alright, let's calculate this. So theta is going to be tan inverse of negative root 3 over 2 divided by negative 1 over 2, or just multiplied by negative 2 over 1. This cancels, the minus cancels, and so we get tan inverse of root 3 minus pi. So let's put that into the calculator, and we get root 3 minus pi. Or I think I need to do minus 90 on this. Yeah, there we go. So this gives me minus 30 degrees, which should be, what, negative pi over 6. Is that correct? Minus pi. Wait. I did minus pi over 2. That's my mistake. It should be minus 120 degrees, which is negative 2 pi over 3. Alright, so the answer is 1 e to the j times negative 2 pi over 3. And yeah, I'm going to do one more example for those that want to stay till the end. But this is pretty much it. That's the whole review of imaginary numbers that you need for this course. Let's do one more. Let's say negative 3 plus 4j, and we want in polar coordinates. So alpha e to the j theta. Alpha is going to be equal to root of negative 3 squared plus 4 squared. So we have root of 9 plus 16, which is 25. Root 25 is 5. This is 5. Okay, and now again for theta, we're going to draw first. And we are at negative 3 and 4. We're in the second quadrant, so we know that we have to add pi. Alright, so theta is going to be equal to tan inverse of 4 over negative 3 plus pi. This is going to give us tan inverse negative 4 over 3 plus 180. Alright. I got a weird angle, but it's correct. It's 126 degrees, whatever this is equal to on in radians. You have to do the conversion here, so you know that, for example, 90 degrees is pi over 2, so 126 degrees will give us 126 times pi over 2, and then all this and divided by 90. So get 126 divided by 2. So it's 63 pi divided by 90. We get 0.7 pi, which is 7 over 10 pi. Okay. It's a bit of a weird number, but it's possible. And so the answer is going to be 5e to the j 7 over 10 pi. Here you go. That's it for this video. If you're able to solve these problems or with any different coefficients for j and a for the real part, and go to the polar form and vice versa, then you're set.